Hello students, good evening all. So welcome back to our next session. So probably this will be our last session in this chapter, on this chapter limits and derivatives. So far we have almost covered our topics related to limits. So we'll just have a quick recap of the topics that we have covered so far, and then we'll see what are the topics. Max, today we are going to discuss about derivatives. So in that derivatives, what in detail topics, the subtopics we are going to see. So that's, we'll just have a look in our overview, and then we'll directly jump into our today's session of limits and derivatives. So if you guys remember, in our previous session, as I already mentioned, this L'Hospital's rule is very, very important, because when it comes to our objective, it actually reduces our time in order to solve the question, right? So if we go by our regular methods like derivation, doing that and all, it actually consumes lots of time, right? But when it comes to objective, we don't need to prove anything, we don't need to show anything, we just need the answer, right? So there we can actually apply this L'Hospital's rule, which is very, very easy in order to get the limit value. But there are some restrictions, like some conditions which we have to verify whether we can apply the L'Hospital's rule or not, and then we can proceed by that, and then we can easily get the answer, right? So we have done lots of questions, we have dealt with questions related to this L'Hospital's rules in our previous session. And after this L'Hospital's rule, in our previous session, we have even covered this concept of trigonometric limits. So if you guys remember, I have given you the working method or the working rule in order to solve the trigonometric limits, right? So what you are going to substitute, how we are going to replace the x, and how we are going to solve those trigonometric limits in order to get the limiting value there, right? The standard way is actually, in place of x, we have to replace with a plus h. So after that, we have to simplify it further, and then we have to check whatever principle applicable there. We just have to go by that, and we'll just get the answer directly, right? So this is one standard working principle in order to solve trigonometric limits. So the next one, so these are the two concepts that we have covered in our previous session, L'Hospital's rule as well as the trigonometric limits. So coming to our today's session, we are going to start with this exponential functions. So here, this exponential function is actually a subtopic of our infinite limits. So we are going to discuss with this infinite limits, where exponential functions is a part of it, right? So as you guys are aware that exponential e power x, so we know, so these are nothing but our infinite limits. So how we can write this? So what will be the expression of it? So that we are going to see first as a standard functions, and then we'll see how we can actually solve these exponential functions when it comes to limits, right? Because here we are everything going to connect with our limits or derivatives, right? So here we are going to see with the limits first, and same with the logarithmic functions. So we are going to see the logarithmic functions and their expansions and their infinite terms, everything, and then how we can solve any logarithmic function if it's a given in terms of limits. Again, here for this exponential functions as well as the logarithmic functions, if you guys are aware of their derivatives, then we can apply the L'Hospital's rules even here, which actually makes the question even easier to get the limit value. Right, so I suggest you, we'll just see first, and I suggest you to go by the L'Hospital's rule because we are going to deal with objective, so it actually minimizes our time. So these are as part of our limits, and the next we are going to see here is the derivative. Right, so we are going to start with the definition of it and the expression related to this derivative and all. And once we are clear with the introduction part, if you remember, of course, I have already given you the introduction regarding the derivative, like the definition of it and the typical representations which we will be using throughout the chapter. So those and all I have already given you the intro where we actually started with this L'Hospital's rule. But again, we'll just have a quick definition as well as a typical representation. But here we are going to see in a different format. Right, so that will be the somewhat a different thing which we are going to learn here in our derivative perspective. Right, and the last concept in our chapter, that is finding the right hand derivative as well as the left hand derivative. So it's like quite similar to our limits. So how we actually find our left hand limit and right hand limit. So as the same manner, as the same way, here we will be having a standard equation, standard terms in order to determine the right hand derivative as well as the left hand derivative. So by applying that, by using them, we are going to find the right hand derivative as well as the left hand derivative here. So these are the four concepts, guys, that we are going to cover in our today's session of limits and derivatives. And with this we can actually wind up our, we are actually finishing our chapter of limits and derivatives. So let's get started with our today's session with this infinite limits, which is with the exponential function first. Right, so first consider a series. So you guys already familiar with the series and sequence, right? So here let's just consider this series where we are having 1 plus 1 by 1 factorial plus 1 by 2 factorial plus 1 by 3 factorial and so on until infinity. So here you can see it is an infinite function. Right, so this infinite series is nothing but denoted by E. Right, so the domain of this function f of x is equal to e power x where x belongs to R. That means we can represent here this function is this entire series which is given is nothing but our e power x. So that's how we are going to represent. So that's why here I have mentioned this exponential function here is nothing but a infinite function. So that's the main topic here we are going to discuss, which is the infinite function. Right, so infinite function, here you can see how many terms you are having here, infinite number of terms. So that's how it will be. So how we are going to represent here? So this entire series is nothing but denoted by our exponential function e power x, which means e power x here will be equal to it will be e. So here you can see it is e. Right, if you want to represent power x, then you will be having x in the numerator, so it will become 1 plus x by 1 factorial plus x square by 2 factorial plus x cube by 3 factorial and so on, because here it's a power x. So generally here this infinite series, in general this infinite series is denoted by e, whereas if we talk about the e power x infinite series, it will be represented by this. Right, as the same way here we will be having the logarithmic. So we already know the relation between this logarithmic and our exponential function. So they are actually inverse to each other. Right, so if you want to represent the log e power x, e power y is equal to x, then from there log x is nothing but y. That means if you have e power y is equal to x, so if we apply log, then it will be log x to the base e is equal to y. So I hope you guys are aware of these conversions, because you will be learning this exponentials and logarithmics, these and all in your 10th or 9th standard itself. So if you guys have any doubts, you can let me know in this concept of exponents as well as logarithmics. But so far you should be, if you guys even remember while discussing the chapter of functions also, we have come across this logarithmic function as well as the exponential function. There itself, there again I have explained you difference between them, like how the inversion of it, how we actually if we have a logarithmic function, how we can convert it and represent it in our exponential function and all. So those and all we have already discussed, right? So here you can see as that is the infinite function. So in this part of infinite functions, we'll be having our exponential as well as the logarithmic functions. So apart from that, here I am going to represent some important functions. So quickly, let's just have a look here. So if you have 1 plus x whole power n. So just get back to our binomial theorem which we have discussed, guys. Any one of you, do you remember how we actually expand any binomial term? Anyone? If anyone remember, please let me know. Quickly, guys, I didn't get any reply yet. It's the basic, right, that we have discussed in our binomial. So if you have 1 plus x whole power n, you are going to represent with n c naught a power x1. So I hope you guys remember. But there is a small trick here. There, while we are discussing our binomial, we always represented the power n will always be greater than or equal to 0. But what happens here? Right. And n will also be positive. So here they have given the condition. So that is the only expansion we will be having. So the same expansion here. If you guys remember that expansion, so that's what we have expanded here. I hope you guys remember. If we have a plus b whole power n, then it will be nc naught a power n b power 0, and then nc1 a power n minus 1 and b power 1. So it will be going on like that. So the same expansion here, but instead of this nc naught and all, we just expanded and written as n, and then n into n minus 1 and so on. Right. So this is the expansion. So let me do that also so that it won't make you confused. Okay. So if we have 1 plus x whole power n, it will be nc naught 1 power n x power 0, and then nc1 1 power n minus 1 and then x power 1. So I'll just write until 2 terms so that you can get an idea, and next terms you can do it n minus 2 and then x square, and so on. You'll be having terms. So let's see the first term. So nc naught, it will be 1 power n, that will be again 1, because anything power 1 power anything will be 1 itself, and x power 0 is also 1. So here it is entirely 1, and here nc1, that means n factorial by n minus 1 factorial into 1 factorial, right? And then 1 power anything again 1 and x power 1 x here, plus nc0 and c2, that is n factorial by n minus 2 factorial into into 2 factorial here, and then x square, and so on. So first term will be 1, second term will be n factorial divided by n minus 1 factorial. So this n factorial can be written as n into n minus 1 factorial, where this n minus 1 factorial will be getting cancelled and we will be remaining with n. So it will be nx, plus here same thing, n into n minus 1, n minus 2 factorial will be getting cancelled, in divided by, in denominator we already having 2 factorial into x square. So now I hope you guys got an idea what will be this expansion, that is 1 plus x whole power, and here is nothing but 1 plus nx plus n into n minus 1 by 2 factorial into x square, and so on. So this is nothing but the same thing which we have learned in our binomial theorem, right? So let's see the exponential part of it. So if you have e power x, so the infinite function which is represented here, the expansion of it is nothing but 1 plus x square by 2 factorial plus x cube by 3 factorial and so on. Right, so same for a power x is also given here, and then we are having for even logarithmic function and trigonometric functions also. Please guys have a look here. So these are all our important functions which we should be aware of them. Right, so as I mentioned, trigonometric functions are also given here. So now our thing is we have to find this limit value. So how can we find that limit value here? Here the function which is given is in terms of exponential, that is it's a exponential function. So how can you do that? Okay, first let me give you this part. So don't use your L'Hospital's rule first, because we'll just as it's a first question, we'll just go by this infinite terms. So we'll go by that, and then we can even go by our after next question, from next question onwards we can go by L'Hospital's rules. For that you should be aware, like before going into our L'Hospital's rule, you should be aware of how we'll be applying our infinite terms here, that our standard functions which you have seen. So we'll just follow that method first, and then we'll just go by our L'Hospital's rule in order to reduce the time. Yeah. So in our previous function, we just denoted our e power x is nothing but 1 plus the standard function x by 1 factorial plus x square by 2 factorial plus and so on. So this is the representation of our exponential function e power x. So can anyone relate this to our given limit function, and how can we solve it? So here we know what is e power x, but here we are having e power x minus 1. So let's get this function and see. So for that, in order to get this e power x minus 1 by x, here we can bring this 1 to the other side, then it will become e power x minus 1 equal to x by 1 factorial plus x square by 2 factorial plus cube by 3 factorial and so on. So now again in the denominator we are having a x. So now to get the x, so let's take x common on the right hand side. Then it will be 1 plus x by 2 factorial, x square by 3 factorial. Obviously third will be x cube by 4 factorial and so on. So now we are having e power x minus 1 is equal to x to the whole into 1 plus x by 2 factorial plus x square by 3 factorial and so on. So now in order to get this function, I can bring the x to the other side, then it will become e power x minus 1 by divided by x will be equal to 1 plus x by 2 factorial plus x square by 3 factorial plus x cube by 4 factorial and so on. So now according to the question, there is a limit for this function. That means in this place of e power x minus 1 by x, we can substitute this equation because both are equal. Right. So now we are having limit x tends to 0 e power x minus 1 by x. So this e power x minus 1 by x is nothing but equal to 1 plus x by 2 factorial plus x square by 3 factorial. Right. So let's substitute that. So limit x tends to 0 1 plus x by 2 factorial plus x square by 3 factorial x cube by 4 factorial and so on. So now here x tends to 0. So let's just substitute 0 in place of x. So all these terms will become 0 except this one, which means this limit value is equal to 1. That means limit x tends to 0 e power x minus 1 divided by x is nothing but equal to 0. Sorry, equal to 1. So this is our standard way applying our standard infinite functions. So we can even go by our L'Hospital's rule also. So let's go by that. So differentiation of e power x will be e power x, and minus 1, differentiation of 1 will be 0, and differentiation of x is 1. And then now substitute in x place, we have to substitute 0, that means e power 0 divided by 1. E power 0 is nothing but 1. So if we could understand, if we could able to know our L'Hospital's rule, so without doing all these entire steps, within one step we just got the limit value of the given function. So that's how we can easily use our L'Hospital's rule and get the answer. Right. So from next question you can apply the L'Hospital's rule, and you can use this limit x tends to 0 e power x minus 1 by x is equal to 1 as a property. So this we can use this as a property, e power x minus 1 by x is equal to 1. Right, so let's go to the next question. So next question is related to log. So as I mentioned, you can directly apply the our L'Hospital's rule. It will be easy. Or if you want to try, you can try by infinite also. Anything is fine. Just take your time, 2 to 3 minutes, and let me know the answer, guys, quickly. So it's related to logarithmic. Or you can go by our infinite values. So just now we have solved one exponential. So check for the logarithmic also, how can we do it? So I'll just give you in. So assume that our given function log of 1 plus x by x is equal to 1. And then try to simplify this. So let me check if anyone has any doubts, any questions. Excuse me. So simplify it. So by doing the cross multiplication and all. So let's do that. So simple cross multiplication, then it will be log of 1 plus x is equal to xy. So now we have to eliminate this log, then it will be 1 plus x is equal to e power xy. So from here e power xy minus 1 is equal to x. Yes or no? So from here we can take e power xy minus 1 by x is equal to 1. Right, so this e power xy minus 1 divided by x is equal to 1. So that's what we got now. So now how can we simplify this further? So this is our function which we have converted in this. So now we can apply our limit. So I have already mentioned the previous one, that is limit x tends to 0. If we have e power x minus 1 by x, then it will be equal to 1. So here you can see, here we are having xy, but in the denominator it's only x. So to get that, we can multiply and divide it by y. That means e power xy minus 1 by, I am just dividing here with y, which means I should multiply with y in order to eliminate that. So now let's apply limit. So limit x tends to 0, e power xy minus 1 by xy. So let it be one term, right? And the other be another term. That means limit x tends to 0 y, and this entirely will be equal to 1. Right, so we know this entire thing according to the previous one which we have solved. If we use it as a property, this will become 1. And then limit x tends to 0 y. So limit x tends to 0 y is equal to 1. That means we end up having limit x tends to 0 y is equal to 1. So now what is the y? So y is nothing but log of 1 plus x by x. That means limit x tends to 0 log of 1 plus x by x is equal to 1. So this is one way of solving the given question. So how we have done this? So we have assumed the given function to be y and then simplified it and converted in terms of exponential. And then the result here which we had is e power xy minus 1 divided by x is equal to 1. But according to the property, if this power and the denominator is same, then it will be equal to 1. The limit value will be equal to 1. So in order to get that, I have multiplied with y and divided with y here, right? So this part is nothing but 1, and here we will be having limit x tends to 0 y is equal to 1, because here we are having both sides. So now limit x tends to 0 y is equal to 1. So that will be our final step. And what is the y here? So y is nothing but our assumption, which is log of 1 plus x by x. So from where we end up having the value of the given limit, which is limit x tends to 0 log of 1 plus x divided by x is nothing but equal to 1. So these two properties, the exponential one and this logarithmic one, you can take them as a properties. You can use that as a properties when you are solving any other questions. You might get a question related to this. Then you can assume, you can take them as a properties. You can remember this, remember them in order to make your time less, right? So let's move on to the next one, guys. So here comes the next one. Quickly, guys, give it a try. It is in terms of sign. So I'll just suggest you to take this as a homework and give it a try, because I have already explained you two questions in this infinite limits concept. So you can take this question as a homework and give it a try. And if you have any doubts, get back to me in our next session and feel free to ask the questions. So now we have done with our limits part of it. Now let's get into our derivatives part of it. So if you guys remember, I have already given the introduction to it. So can anyone give me the definition in your own words? Anyone? So basically what you guys are thinking about derivative. So in your words, what is the definition of it? Anyone? Okay. So basically the definition for derivative is nothing but it is a rate of change. So rate of change of one function with respect to the another function. So in general, right? So here the definition here is nothing but the instantaneous rate of change of a function with respect to the dependent variable. That means if y is equal to sin x, then y is a dependent or independent. So y is actually dependent on the x and x is the independent variable. That means if you are having some function, so in general, if you see, you'll be in your physics, you'll be seeing dv by dt, dA by dt, or something like that. So dv by dt, right? So the same concept here, rate of change of one function with respect to the another function. In our mathematical terms, we'll be using our x and y variables here. So dy by dx. So we always go by taking with respect to the x here. So that is the general definition. So you can remember it like rate of change. That would be enough. So let's see how we can actually derive the formula for this, how we can denote it. So as I mentioned, we can denote this derivative as y dash dy by dx or f dash of x, or you can remember, you can denote as delta y by delta x, right? So here, that's what the representations we'll be using for the derivatives. So first, let's consider a function f, right? So let f be a given function of one variable and let dx denote a number to be added to the number x, right? So this dx is the small change of the number, right? If you are having function f of x, right? So you are having a function f in terms of a variable x, but there is a small number, that is a delta x, which is added to this number. That means x plus dx. Then there will be obviously a change, right? So let me take, if I am having a number 8, so this is my variable, for example. If I am adding my delta x, that means 0.01. If I am adding that, then it will become 8.01. So now if I want, what is the change here? The change is nothing but my f here is 8 and my delta x here is 0.01. If I want to know my change is nothing but my f minus my f of x minus this delta x. That means 8.01 minus 8. Yes or no? Let me write it clearly. So let's take f here to be 8 and our delta x dx to be equal to 0.01. So if I add, then means my f of x plus this dx, after adding, I'll be having 8.01, right? But if I want to get my change, what is the change of my function f of x, then it is obviously 8.01 minus 8, that is only my change 0.01, which means 8.01 is nothing but f of x plus dx minus f of x. This is nothing but my change of the function, that is dx. So this is the entire change of the function, which will be representing as df, which is the function. Right, thus this entire change is nothing but with respect to the variable x, so it will be delta x and delta x in the denominator. So in general, your derivative of a function, so the formula will be is nothing but, so just now we have seen our df, how we have represented. So it will be represented with this format: delta f by delta x is equal to f of x plus delta x minus f of x divided by delta x. So if you want to find the derivative, so this will be the formula which we'll be using: delta f by delta x is equal to f of x plus delta x minus f of x. So I have explained you how we end up having this with a simple numerical example just now, right? So this df is the change part, and this is change with respect to f, with respect to the x, and this will be the entire derivative, right? So if this df by dx, if that approaches to 0, that means our delta x, that is nothing but, so this is delta x, so that is nothing but obviously approaching 0. Right, because this is with respect to our x. If that's approaching 0 means our dx will also be approaches 0. Then means now approaching 0, how can we represent that? That will be represented as a derivative of a function f using the symbol of our limit. Right, so if this delta f by delta x approaches a finite value as dx approaches 0. So if dx approaches 0, so this limit is the derivative of the function f at the point x. So that will be the derivative. So then it means limit. Now we can apply limit where this delta x part will be approaching 0. So here, as I mentioned, delta x approaches 0. So as delta x approaches 0, so limit delta x approaches 0, delta f by delta x will be equal to limit on the both sides. We are just applying this limit part for what equation we have derived in the previous slide. So f of x plus delta x minus f of x by delta x. So this is our limit derivative of a function f. Right, so df by our delta f by delta x will be the derivative. As in limits, here it will be the representation as delta x will be approaching 0. So now the same thing, how we have in limits the right hand limit and left hand limit. In the same manner here we will be having a right hand derivative as well as a left hand derivative here. So let's see the equations related to the right hand derivative as well as the left hand derivative in order to predict the values. Right. So you might wonder why we actually require this left hand limit and right hand limit, because you can use this equation in order to find the derivative. Right, but here the application part of this right hand limit and right hand derivative and left hand derivative is to determine whether the given function is differentiable or not. Right, so you will be learning this concept of differentiability as well as the continuity in your 12th standard. So that's why I'm not talking about that right now. But while you are 12th, you are dealing with this differentiability. For that, you should aware of this, how you will be determining this right hand as well as the left hand derivative. So let's have a look and see how can we find the right hand derivative as well as the left hand derivative of any given function. Right, guys? So the right hand derivative, we know it's a positive. That means at x equal to a, if we are finding, then it will be a plus. Right, so that means this will be our right hand derivative. Right, that means f dash a plus. So as it's a derivative, we know it will be represented with dash. So it is denoted by limit h tends to 0 f of a plus h minus f of a by h. So this equation will be giving you the right hand limit. So can you guys tell me what will be then left hand limit? Same, almost. In place of a plus x, we will be having a minus h, and then we will be having minus h in the denominator. So the left hand derivative of the function f of x at x equal to a, in general it is denoted by f dash a minus. So for right hand it will be f dash a plus, and these are denoted by limit h tends to 0. We are entirely converting in terms of h. By replacing in place of x, we are going to replace a minus h here, x plus delta s, then it will be f of a minus h minus f of a divided by minus h. Then what about the right hand limit? It will be f of a plus h minus f of a divided by h. So this will be the right hand limit. So these are the equations we will be using throughout the derivatives in order to determine the left hand as well as the right hand limit. And the first equation is all about finding the derivative. Right. So as I mentioned, these left hand limit and right hand limit are actually in order to say whether the given function is differentiable or not. right, that is derivable or not, right? So here hence f of x is said to be derivable or differentiable at x equal to a if f dash of a plus is equal to f dash of a minus is equal to a finite quantity. That means the right hand derivative must be equal to left hand derivative, and this must be a finite value. Finite value. Right, so then we can say the given function is a differentiable function. Right, so you will be learning this most related things related to this differentiability and all in your 12th standard. So but now you should be aware of why, what is the reason, what is the importance of finding this right hand as well as the left hand limit here. Right, so in general this left hand and right hand derivatives will be denoted by R f dash a, that means right hand derivative, L f dash a, that means left hand derivative. So in another way we can represent f dash a plus, that's also right hand derivative, f dash a minus, which also means the left hand derivative. Right, so now as we have seen our things, our introduction, everything related to the derivatives. So now let's jump into the questions related to this and see how we can solve the questions related to this derivatives. So quickly have a look over the question, guys. Read it carefully first. So find the derivative of f from the first principle where f is given by. So we have to follow the first principle here. So what is our first principle? So we have learned that delta f by delta x is equal to f of x plus delta x minus f of x by delta x. Right, so we have to, where delta x tends to 0, that will be our derivative, that means limit delta x tends to 0, limit delta x tends to 0, that is in general. Right, so delta f by delta x, so this will be our derivative for any function. In order to find the derivative of it, we have to follow this equation. So now here the given function is 2x plus 3 divided by x minus 2. So let's find that. That means this is our f dash x. So I'm going to write it to be f dash x. And here limit delta x tends to 0. Here we are going to have f of x plus delta x. That means in place of x, we are going to have this x plus delta x. So it will be 2 x plus delta x plus 3 divided by x plus delta x minus 2 minus f of x. So directly 2x plus 3 by x minus 2, and in the denominator it will be delta x. So quickly simplify it, guys. So I hope this delta x, writing this, it will be a bit difficult. So what you can do is replace this delta x with h. Then it will be easy. So let me write in terms of h so that it will make representation easy. So f dash x will be equal to, so I am replacing the delta x with h, so h tends to 0, f of h plus x minus f of x divided by h. So for this first one, let's do it, guys. So limit h tends to 0. In place of x, we have to substitute this x plus h. So 2 into x plus h plus 3 divided by x plus h minus 2 minus 2x plus 3 divided by x minus 2, entire equation divided by h. So here we just have to simplify it. So first we have to simplify it. So let's do that. And let's do the simplification, guys, and let me know the answer quickly. I'll be looking for your answers quickly. So let me do you alongside. So we have to go by this LCM and all. So x plus h minus 2, x minus 2, and let it be in the denominator. So it will be multiplied with x minus 2. So it will be 2x plus 2h plus 3 entirely multiplied with x minus 2. And here minus of 2x plus 3 will be entirely multiplied with x plus h minus 2. Right, so we have to simplify it. So just do the multiplication part and see what will be the numerator. So limit h tends to 0, a bit lengthy, but you can do it, just a simplification, that's it. So 2x square minus 4x 2xh minus 4h plus 3x minus 6, and then here minus of the entire thing. So 2x square and then plus 2xh and then minus 4x and then 3x plus 3h minus 6. In the denominator we are going to have x plus h minus 2, x minus 2 into h. Right, so let's solve the numerator. I'm just writing it here. 2x square 4x plus 2xh minus 4h plus 3x minus 6 minus 2x square minus 2xh plus 4x minus 3x minus 3h and plus 6. So this plus 2x square and minus 2x square will get cancelled, this and this will get cancelled, and this will get cancelled, plus 3 minus 3 minus 6 plus 6, and we are left with minus 4h minus 3x in the numerator. That means minus 7h divided by all the denominator. So let me erase this part and write it clearly. So now we are having limit h tends to 0 in the numerator minus 7h, in the denominator x minus 2 and x plus h minus 2 and then h. So this h and this h will obviously get cancelled, right? And then what else we have to do? Let's substitute h0. Then it will be minus 7 by x minus 2. If I substitute 0, it will be x minus 2. Then it is equal to minus 7 by x minus 2 whole square. So this will be the f dash x. So the derivative of the function f of x according to the first principles. So f dash x here is equal to minus 7 by x minus 2 whole square. Right, so this is how we'll be finding the derivative using the first principles. But again, yeah, in your 12th standard you are going to learn the chapter of differentiation in detail. So there you won't be following this first principle and all. So you'll just following the standard methods which they'll be mentioning, which you are going to learn in your differentiation chapter. So as I have given you the first bit how to solve it, so I can give you the second part as a homework. I hope you guys can give it a try for the second bit. Right, so just take the second one as a homework and give it a try. So let's move on to the next one, guys. So we have seen how to find the derivative from the first principles. I have explained you one question in detail. So now let's see how we can find the right hand derivative as well as the left hand derivative of the function. So I am not going to explain this, guys, because you have already done this finding left hand limit as well as the right hand limit. So somewhat similar to it. So you guys can do it. So give it a try first. Give it a try, guys. Okay, I'll just write down the right hand derivative and left hand derivatives expression first. Here I'll be writing. So a plus right hand limit derivative f dash. Okay, so it will be limit h tends to 0 f of a plus h minus f of a. So don't be confused with this h and delta x. So they are actually the same thing. So instead of writing this delta x repeatedly, it will be easy to write this h. So this is for right hand. First try and find the right hand derivative, guys. So here a is nothing but 3. Come on, guys, did anyone got the right hand derivative? So just see, just follow by this. Here function is given and the a value is given. So let's see here. For the first one, it's obviously greater than 0, which means what will be your function there? So let's substitute it here. That means f dash for right hand derivative, it will be 3 plus. Right, which means limit h tends to 0 f of what is a? 3. So it will be 3 plus h minus f of 3 divided by h. Yes or no? So now we have to identify the function f of x here. So what will be the function here, guys? So here it will be, the function is, the x value is 3 plus h, which means greater than 3. So when x is greater than 3, what will be the function f of x? That is x plus 2. So now it will be limit h tends to 0. In place of x, it will be 3 plus h plus 2. Minus here it is exactly 3. So obviously 5. So minus 5 divided by 4h. So 3 plus 2, it will be 5. 5 minus 5, it will be 0. And h limit h tends to 0. So this will get cancelled, which is equal to 1. Which means my right hand derivative here is equal to 1. So let's check the left hand derivative. F dash 3 minus limit h tends to 0 f of 3 minus h minus f of 3 divided by minus h. So here it is less, so it will be 8 minus x. So 8 minus 3 plus h here minus, again at 3 it will be 5 divided by minus h. So 8 minus 3, 5. So 5 minus 5, 0. And then we'll be having h minus h. H divided by minus h. So h cancel, minus 1. So now you can identify the left hand the left hand derivative is equal to minus 1. Whereas the right hand derivative is equal to 1. Right, so here the question is to find out the right hand derivative as well as the left hand derivative. So right hand derivative is 1, left hand derivative is minus 1. Right, so let's have a quick question on this same concept. Okay, yeah, give it a try. Same methodology but a bit tricky because it's given in terms of sine trigonometric functions. So same thing, you have to figure out the right hand derivative as well as the left hand derivative. So same methodology guys, only the function will be changing. So that's all. Quickly. So let's see what happens to right hand derivative. So here x is, here at x equal to pi by 2. So we have to find at x equal to pi by 2. So f of pi by 2 plus for right hand derivative. So limit h tends to 0. F of a here is pi by 2. So pi by 2 plus h minus f of pi by 2 divided by h. So let's figure out the function and then substitute it here. Here it is greater than pi by 2. Then what will be the function? So it is 2 plus x minus pi by 2 whole square. So limit h tends to 0. So 2 plus, in place of x, pi by 2 plus h minus pi by 2 whole square. Minus at equal to pi by 2, it will be 1 plus sin x. So it will be 1 plus sin pi by 2. Because x is nothing but pi by 2. In the denominator, it is h guys. So pi by 2 and pi by 2 will be cancelling here. So limit h tends to 0. So it will be 2 plus h square, it will be, and then 1 plus sin 90, it will be 0. So it will be minus 1. Sorry, sin 0 will be 0, sin 90 will be 1. So it will be 1 plus 1 again 2. So minus 2 divided by h here. So plus 2 and minus 2 will get cancelled. 1 h here will get cancelled. So here it is limit h tends to 0 h. That means we can substitute h equal to 0, which will be equal to 0. That means the right hand derivative for the given function is equal to 0. So let's do the left hand derivative also guys quickly and let me know the answer. I'll just write you the text here. Quickly solve it. Identify the corresponding function. So here you can see obviously the x is less than pi by 2. So we have to check the function where x is less than pi by 2. So that means it is 1 plus sin x. Right, so let's do that. So less than equal to. So limit h tends to 0. So 1 plus sin, in place of x it will be pi by 2 minus h. Same thing here, pi by 2 for equal also same thing. So it will be 1 plus sin pi by 2 divided by h. So let's simplify it further. So limit h tends to 0 and 1 plus sine pi by 2 minus means it will be cos h according to our trigonometric properties, and minus here 1 plus 1 it will be 2, so minus 2 divided by h here, which means limit h tends to 0 cos h minus 1 by h. Sorry, it's a negative, right? So we'll be having minus h here, left hand, right? So it will be cos h minus 1 by minus h. So this can be rewritten as limit h tends to 0. If I take minus in the numerator common, then it will be 1 minus cos h by h. Right. So now we are having 1 minus cos h by h. So now we can go and apply our L'Hospital's rule in order to get the value. Right. So let's go by that. I'm just erasing this part. So after the entire simplification, we end up having limit h tends to 0, 1 minus cos h by h. Right, so let's go by our L'Hospital's rule because both the numerator and denominator will become 0 by 0. So 1 it will be 0, so cos h it will be sin h minus sin h, so minus into minus plus sin h divided by 1. So limit h tends to 0. Right, if I substitute 0, sin 0 will be 0. Right, so now you can see my right hand derivative which I got, that is also 0, and my left hand derivative which I got right now, that is also 0. So here according to the question we have to find the right hand derivative as well as the left hand derivative which we have found out. Right. So you can do this question as homework, guys. One question for homework. So today I have given around 3 questions for you guys to work it on as homework. So do those questions and get back to me if you have any questions in those questions or in regard of those concepts. Right, guys, so that's all we have done with our limits as well as the derivatives. Yet again we are having this continuation of this chapter will be in your 12th standard, which will be continuity and differentiability. In detail you are going to learn in your 12th standard. So that's all for today, guys. If you please do the homework, and if you guys have any queries, any doubts in the regard of this entire chapter, limits and derivatives, please feel free to contact me. Right, so that's all then. Thank you, guys. We'll just start a new chapter in our next session.